So today we're going to go over empirical formula. And the empirical formula of a compound is the simplest whole number ratio of atoms in a molecule. And we can determine that from experimental evidence. And it's not necessarily the molecular formula of the compound. That will be some multiple of the empirical formula, even if that multiple is 1. It's outside the scope of this video, but we will be covering it. So let's look at nicotine. Nicotine is 74.03% carbon, 8.7% hydrogen, and 12.27% nitrogen. That is enough information for us to get the empirical formula of nicotine. So what's our process? Our process is going to be to assume a 100-gram sample. No matter what size sample we have, these percentages remain constant. After that, we're going to convert to moles and then compare mole-to-mole ratios. So let's get started. Converting these to grams is simple. If we have a 100-gram sample, all of the percentages just become gram numbers. So 74 grams, 8.7 grams, 12.27 grams. Next, we're going to convert these to moles one at a time. We'll start with carbon, and converting that to moles means dividing by its atomic mass, and we get 6.17 moles of carbon. Next comes hydrogen at 8.7 moles. Next comes nitrogen at 1.233 moles. Now the thing to notice here is that nitrogen is the smallest number of moles present. So we're going to see how many moles of everything else is there compared to the amount of nitrogen present. So this is our mole-to-mole ratio phase. And in this phase, we're going to compare the amount of carbon present relative to the amount of nitrogen present. Same thing with hydrogen, and same thing with nitrogen. Everything gets compared to nitrogen. When we do this for carbon, we come out with 5.01, which is pretty close to 5. When we do it for hydrogen, we come out to 7.06, which is pretty close to 7. Turns out that I'm able to round in these instances. And when we do it for nitrogen, a number divided by itself is 1, which means that the simplest whole number ratio of atoms we have in this molecule is C5H7N1, or C5H7N. And that is the empirical formula for nicotine. Now let's try it again with another substance where this rounding isn't going to work out so well. So here we have some mystery compound where its percent composition is 25.9% nitrogen, 74.1% oxygen, and we want to come up with the empirical formula. So again, our process is assuming a 100-gram sample, converting to moles, and comparing mole-to-mole ratios. So assuming 100-gram sample is pretty straightforward. We have 25.9 grams of nitrogen and 74.1 grams of oxygen. Converting to moles, again, dividing by the atomic mass of nitrogen, we get 1.848 moles of nitrogen, and 74 grams of oxygen turned into moles is 4.633 moles of oxygen. Now again here, the smallest number is the number of moles of nitrogen. So we're going to compare everything to that. So our mole-to-mole ratio, moles of nitrogen compared to moles of nitrogen, comes out to be 1. And our moles of oxygen compared to moles of nitrogen comes out to be about 2.5. Now I really can't round that to 3. What I'm going to do is say that the empirical formula is nitrogen, oxygen 2.5. But that's not the simplest whole number ratio. I need to make that a whole number ratio by multiplying by 2. So when I multiply by 2, I get a whole number ratio of N2O5. It turns out that that is the simplest whole number ratio. It's just not easily divisible by 2. So when we think about all of this, we're going from experimental evidence like percentage or grams to a formula. And the empirical formula is the simplest whole number ratio of atoms in a molecule and the application of a gram to mole conversion. So this is the first time we're actually doing something with this conversion. Now let's try this. A molecule has the following percentages: 4.9%, 49.4% carbon, 5.15% hydrogen, 28.8% nitrogen, and the rest is oxygen. You'll have to calculate how much oxygen there is. What is the empirical formula? If you do it right, C4H5N2O. Thanks, and we'll see you in class.